Hello everyone, welcome to Keep Learning at the rate Be Creative. So today we are going to discuss another important theorem related to circles and tangent. Before moving to the proof of this theorem, if you have not subscribed the channel, please subscribe the channel and hit the bell button so that you can get the latest update regarding the new videos. So let's move to the proof of this theorem. So the theorem says the length of the tangent are drawn from external point to a circle are equal. So what we need to prove is that if we draw the tangent from an external point P, then the length of the tangent are equal. Important thing, that what is length of the tangent? The length of the tangent is the distance from this point P to the point of contact between the tangent and the circle. So Px is the length of the tangent and the second tangent from P is that Py. So we need to prove that Px is equals to Py. So let's begin with the proof. We have been given a circle with center O, P lying outside the circle, two tangent Px and Py on the circle from P. So we have this point P lying outside the circle and Px and Py are the two tangent from point P. We need to prove the length Px is equals to Py. For this we are going to join PO and Px and Py. Why are we doing so? Because whenever you need to prove some angle, some segments equal, try to find out certain triangles which can be proved congruent. If you are able to find the triangles, then after proving them congruent by CPCT, you can very easily prove the respective parts equal. Here, as we need to prove Px is equals to Py, we can imagine that if we connect P to O and Ox and Oy, we get two triangles. So let's see how are we going to prove these two triangles congruent. So here it's very clear that Px is the tangent through x and Ox is the radius through x. So definitely Ox will be perpendicular to Px. Similarly, we can say that Oy will be perpendicular to Py. So these two angles will be 90 degree. Next, we can say that in right triangle OXP and OYP, we can see that angle OXP is equals to angle OYP, which is equals to 90 degree. Just now we have understood that OY and OX are perpendicular to the respective tangent. This is a theorem which we have already studied. Now, next is OX is equals to OY. Why? Because they are the radii of the same circle. Next, we have OP is equals to OP, which is common in these two triangles. So we can very clearly say that these two triangles, that is OYP and OXP, are congruent by right angle hypotenuse side. See, we used a right angle, then we used the OP, which is the hypotenuse, and another side OX equals to OY. If you have any doubt regarding this, how the radius is perpendicular to the tangent, then you can see the video to prove this, that the tangent is perpendicular to the radius at the point of contact. The link to the video is given above. Now, as we have already proved that these two triangles are congruent, hence we can say that Px is equals to Py by CPCT, that is corresponding part of the congruent triangle. Now, after proving this, do we had certain other observations in this triangle? Let's see what other results we can say. So, in these two triangles, we can also prove this theorem by the help of Pythagoras Theorem. How? See, we have already proved that this angle OYP and angle OXP are right angle. So, we can apply the Pythagoras Theorem in triangle OXP, in which OP is the hypotenuse as it is in the front of 90 degree. So, we can write Px square is equals to OP square, that is hypotenuse square, minus OX square. This is your px, which is the length of the tangent, that square is equals to OP square, that is the hypotenuse square, minus OX square. Now here we can replace OX by OY. Why? Because they are the radii of the same circle. Now OP square minus OY square, what does this mean? OP square minus OY square. So from this triangle we have moved on to this triangle. In this you can see that OP square minus OY square will give you PY square, as again this is a right angle triangle and here OP is the hypotenuse and PY and OY are the perpendicular legs. So here we can replace OP square minus OY square by PY square by using Pythagoras theorem. So here, which gives us the result that Px square is equals to Py square, and if you take the square root on both sides, you will have Px is equals to Py. Also, we can prove that angle OPX will be equals to angle OPY, which is again an important result. Here by CPCT we can prove that these two angles are equal to each other. Also we can conclude that OP is the angle bisector of angle XPY, because you can see that these two angles are equal. So it is dividing angle XPY into two parts which are equal in measurement. So that's why OP is the angle bisector, or it's working as an angle bisector for this angle. What else we can say? See, here we can say that PXOY is cyclic. Why? Because here you can see the opposite angle PXO plus angle PYO, that is 90 degree plus 90 degree will give you 180 degree. And in this quadrilateral PYOX, the sum of the opposite angle comes out to be 180. So we can say that this quadrilateral is cyclic. Also we can also conclude that PO will be the diameter of this circle. Why? Because you can understand that this angle is 90 degree. So we know that angle in a semicircle is always a right angle. Definitely the circle which is circumscribing the quadrilateral XPYO, in that OP will be the diameter. Also we can say that angle XPY plus angle XOY equals to 180 degree. This type of questions are generally being asked. You may be given angle XPY and you may be asked angle XOY. So if it is an objective question, you can directly answer, as you can see that angle XOY and angle XPY are also supplementary. Next, what else we can prove here is that angle OYX, angle OYX and angle OPX are also equal, because they are angle in the same segment. If this quadrilateral is circumscribed by the circle, then OX is subtending angle XYO and XPO on the circle, that is the circumference or the boundary of the circle. So that's why we can say that these two angles will be equal. Also in the similar manner we can prove that angle OXY will be equals to angle OPY. I hope you have understand all the result. These are the small result on which the direct questions can be framed in your examination. I hope you have understood all the concept, and also you can apply these concepts in your examination. Thanks for watching the video. If you like the video, please hit the like button and also subscribe the channel for more such videos. Thank you.